This is Sunday, August 2nd. Last Sunday I ordered these, and they came from PCB Way. Now shipping on this was $15 or $18. But they were put in the shipping process, I think, Wednesday, Tuesday at the latest. And they delivered them to my house on a Sunday. The actual cost of these was $5. Appears like they're vacuum sealed. So I think, I'm not sure yet, that these are PCBs for prototyping my little voltage references. It looks like PCB Way, who's been in business 6 years, that this little numbering system, which will disappear when I install the resistor. What's the last number? Is that 5F1 maybe? That's the number that appeared on this wrapper. So the software I used to develop these boards was free, and these boards would have cost, or did cost, these boards did cost me $2.50 a piece, or less than that. Like I said, I think the charge was 18 plus 5, maybe plus 2, I'm not sure. It's been like 35 years since I've made my own circuit boards. And that was a very laborious process of drawing out the traces on using ink on Mylar to 4 times actual size, having them photo reduced to a negative, buying pre-sensitized, pre-cut boards, laying the negative over the board, exposing it to ultraviolet light, dissolving away the copper in ferric chloride, and then using a silver solution, plating on the traces, then drilling all the holes on a drill press. And those were, in those days, it was all single-sided. Silk screening involved another negative, and then wiping ink back and forth across a mask. It was very involved. So now I'll see if the holes and the traces are correct, because I did not do a schematic and have the software convert it to a board. I laid the board out dimensionally and connected the traces. The software would have done that had I drawn the schematic first and then converted it to a board using the software conversion feature. The software I used to develop the files for this board was produced with a thing called DipTrace. DipTrace. One word. And I'm using a free version of it. After I got the board, well, before I got the board, I realized this link was missing. So I added that link, and I've added it in the screenshot. You can see there's a link there. And I took advantage of this relatively unpopulated area up here to put some white silk screenings on so I could write output voltage and date and whatever I need to do. And I looked at these little thin traces. There you can see them real well. The only thing I have at the back of the board is ground. So I didn't do a two-sided board. I mean, I just filled the areas that could be grounded with copper. I didn't add copper. I reduced the amount of copper that had to be etched away. But here I do have the circuitry. And so I decided I wanted to make these lines thicker, these traces thicker. And so these are 0.013 millimeters. These traces are 0.04 millimeters. DipTrace has an awful lot of features. Frankly, it seems to do more than I can do in AutoCAD, really. But it does require learning if you want to draw the circuit and then let the software import the circuit onto a board. But this was relatively painless. I thought there would be more conversations back and forth between myself and the board maker. Instead, there were none. I uploaded the Gerber file, which is produced by this, and they analyzed it and gave a thumbs up or a thumbs down. DipTrace, a very useful piece of software. Here's the little reference board bolted to two 9-volt battery jacks. This thing. I'm only using two of the holes, this one and this one. And I fastened them on just for shits and giggles with nylon or polypropylene hardware. See, the nut's not bad there as far as, well, we'll get to that. I need to add 1/10 of an inch to this bar. I didn't allow enough center-to-center holes. That will put it really close to this nut. So I've got to think about that. You see this resistor here. When I decided to lay out this board, I decided to try to duplicate Joe Geller's SVR board, in which case the center of this pot would be connected via J1 to the trim connection. Some devices using this pinout require a resistor in this between the potentiometer and the trimmer. So this I'll label this probably L1. This is a link that just continues this connection to J1 via and on to pin 5. This resistor is not installed. If you're going to use one of the analog device 6 or 7 series, that analog devices does not recommend any resistance in this between the center of the pot and that. In which case a wire link would be installed here, and this resistor not installed. If you're using a device that wants some resistance between the center of the pot and the trimmer, you would leave that wire link out and install that recommended resistor here. So here's the voltage reference board built up as an SVR. You see the little wire link. These are the 2 resistors that recommended by Joe. This is a 1K pot. This is a shorted LED, which is why it's not lighting. And this is just a current limiting resistor for the LED. 2 recommended bypass capacitors. Now this is a 5-volt device, the 586, which means that you could have used one 9-volt supply for a 5-volt output. But a lot of people want a 10-volt output. They would use a 587. That's why I have provisions for 2 batteries. I've assembled it and hooked it to the Hewlett-Packard meter. And I don't know why. Maybe because it's a printed circuit board. This potentiometer, and maybe I used a better potentiometer. This potentiometer works extremely well. I don't have the other camera set up. The adjustment just works so much better. Now, I don't have it hooked to batteries. I'm going to age it on an 18-volt supply. So now I've got a universal, or more or less universal, board. I think I'll try some other devices made by somebody other than analog devices.